Okay, this question, this is chapter 15, kinetics. So in this one, in class, we actually did change this question a little bit because it was just, they were trying to make it too difficult. So we went ahead and changed this to the initial rate being equal to, for trial 3, so I'll go and label these 1, 2, 3, 4. The initial rate being 0.014. Okay, so when we look at this, we want to infer from this data what the order of each reactant is. So in order to do that, we have to pick two trials where one of the concentrations doesn't change and the other one does, and then see how does the rate change based on the change in concentration. So let's start with determining the order of CHCl3. Okay, so we want the Cl2 to be held constant, and we want CHCl3 to change and also see how the rate changes. So ones were held constant, we're going to use trial 1 and 2. Cl2 stays constant, and CHCl3 doubles. Okay, the rate also doubles. So if they do the same thing, that means the order is equal to 1. If the concentration doubled and the rate quadrupled, that would be second order. If the concentration doubled and the rate stayed the same, not just doubled, but it actually didn't change at all, that would be 0 order. So you're using trials. This is the first way to determine order. The second is through plotting. You're using trials to see how does change in the concentration affect the rate. If it has no effect, then that's 0 order. If it has the... Goodbye. That was my kids. If it has change in the concentration has the same effect on the rate, so double the concentration, double the rate, then that's first order. And if it has an exponential relationship where you double the concentration and quadruple the rate, then that's second order. So in this instance, the CHCl3 order is 1. The order of Cl2, we're going to pick a trial where CHCl3 doesn't change. So that's trial 2 and 3. And here, Cl2 doubles, the rate also doubles. So the order here is also 1. Okay. So another thing we can do here is write the rate law. Rate equals K, CHCl3, 1. Put the order up there, Cl2, 1. So the overall rate of this reaction, the overall order, if we add the two orders together, the total order is 2. Okay. The other way we tell that is by doing plots. Now in this one, you can see that for a first order reaction, when you plot concentration versus rate, you get a straight line. In this case, when you plot concentration versus rate, it's not a straight line. That's because for second order equations, you have to plot 1 over concentration versus rate to get a straight line. So look at a couple problems like that. That's the other way to determine order. This one doesn't really apply in this instance. It's just telling you there's an exponential relationship here between changes in concentration and the change in rate. Okay, what the question really is asking for is this, or the order of this reactant and the order of that reactant.